Hey, good afternoon, everyone. I would like to welcome you all to this special event of the Transit Analytics Lab. So we are honored today to have our distinguished guest speaker, Jacqueline Darwood, who's going to share her thoughts and insights on the critical and timely topic of transit safety and security, which I'm sure all of you, it's in the minds of all of us. So I'll start first with the land acknowledgement, and then I'll say a few words about TAL before introducing our guest speaker more formally. So I wish to acknowledge the land on which the University of Toronto operates. For thousands of years, it has been the traditional land of the Huron-Wendat, the Seneca, and most recently, the Mississaugas of the Credit River. Today, this meeting place is still the home to many Indigenous people from across Turtle Land, and we at the University of Toronto are grateful to have the opportunity to work on this land. So before starting the main feature of this event, let me say just a few words about TAL. So the Transit Analytics Lab was established in 2020 to serve as a common forum for promoting transit decision-making using data analytics. TAL actually brings together transit and tech researchers from across the university. It also brings together transit systems and public sector practitioners, as well as private sector vendors and consultants. If you're probably have been exposed to some of our activities, TAL undertakes a wide range of activities in research, innovation, and training, and it brings together the academic and professional communities to share knowledge and foster collaboration. So in this spirit, today's event features a talk on the very critical topic of transit safety and security by our distinguished guest speaker, Jacqueline Darwood. Jacqueline is an experienced transit and mobility professional with over 25 years of experience in transit operations and planning, infrastructure planning, project management, and policy development. So over the course of her career, Jacqueline has worked in both the public and private sectors across Canada. She has led and contributed to the planning and design of rapid transit and commuter lines in British Columbia, Ontario, with major projects in Ottawa and the Greater Toronto and Hamilton area. Jacqueline's work on several bus networks includes the TTC Express Bus Network. I didn't know that, Jacqueline. The MiWay Transit Way, and the redesign of the bus network in the Kingston Metropolitan Region in Jamaica. Very interesting. So to her friends and family, she's known as the entertainer and personal shopper, always ready to host a barbecue, dinner, or a movie night, or simply get lost in the world of music, which all sounds good. We need someone with a relaxed attitude to tell us how to improve transit safety and security. So without any further ado, Jacqueline, it's over to you.
Thank you so much, Amr. Okay, good afternoon, everyone. I'm happy to be here. I am going to be talking about improving transit safety and security, but I am not going to get into the politics of it in terms of what has been happening. I am more going to be speaking from a planning and an operational perspective as to how we can improve transit safety and security and some of the work that has already been done. I'll start by acknowledging that there's lots of work that has been done in preparing for this presentation. The reading is extensive, and for those who are interested, I could provide a reference list. There is a lot of different research and certainly a lot of different technology that is emerging on this topic. So without any further ado, I'll move to the next slide. Okay, so today we're going to be, I'll of course introduce the topic, and I'm going to be talking about the topic from a planning for safety, security, safe operations, and monitoring, looking at what new technology is currently evolving, what is out there, and some of the very far-reaching ideas that has come out in terms of transit safety and AI and the Internet of Things, and how all of this is evolving, and how, if possible, we can collaborate and extend the research on some of what has been done previously. Next. Okay, so I'm having a little bit of trouble here because people are showing up. Okay, all right. So transit customers rely on transit operations to provide reliable and safe day-to-day public transit. Now, you might wonder why I start off by saying this, because we all want transit to be reliable, but if it's not safe and you have either accidents which are deliberate or accidents because of a failure of a system, then of course the service breaks and you're going to have either the absence of the service or delays in the service. So it's from that standpoint that will try to tie safety with reliability. To improve safety and reliability of transit systems, many key engineering implementations and innovations have taken place, which include improvement in station planning, design, rail operations, and simulation. And I will focus most of my discussion on station planning and rail operations, because that's where I have I've done some work with different clients while I was in the private sector. I currently, or I should preface by saying I'm currently working with the City of Toronto, but as Amma said, I have spent some time on both sides of the coin in this transit-related environment. In addition, based on recent facts and evidence, their extreme physical and cyber threats become more common and even more dangerous to the public. So recently, we've heard a lot of different attacks, assaults on the TTC. For example, the TTC has said that the rate of assaults on their lines on passenger customers have increased by over 46% compared to pre-pandemic times, and certainly something to be alarming. It's certainly alarming, but there are different factors that are contributing to that, and that will take another series of presentation to get into that. Next slide, please. Next slide. Okay, so what are the factors that impact transit safety? It's directly impacted. The angle I'm going to take it from is from the angle of the plan, design, and operations of the system. So how was the system planned? How is it designed? What is it relying on? And in terms of operation, how is it being monitored? And what are the factors that are being considered as part of the operation? What are the systems in place as part of the operations? How can transit safety and security be improved? There are, as I said, there are many deliberate acts against transit infrastructure, and sometimes the infrastructure itself fails because probably of poor maintenance or design defects. So there is room for improvement there, but there's also room for improvement in terms of our planning and monitoring and the day-to-day operations. What are the tools and technologies that can be used to improve transit safety and security? Right now, there's a lot of talk around artificial intelligence. Passenger modeling has certainly evolved. There are several software out there. I'm going to try to avoid mentioning any directly by name because I'm not here to promote any of them, but there are quite a bit of passenger modeling and vehicle modeling software currently in the market. And I know that Amber, for example, was recently involved in a study to bring both the passenger modeling and the vehicle modeling together to show how we can improve the design and planning and operation of transit. Next slide, please. Okay, so rail infrastructure there and how this is impacted by safety. There are several different components to rail infrastructure, and by no means is this an exhaustive list. I just quickly went through the ones that are very top of mind with most people. So the rail gradient and alignment, ventilation systems, stations, communications, signal systems, and in recent times, I think before the whole conversation about new subway lines and all that started, it was around signals, and TTC was very much telling us about It's automated train control systems that it had introduced, which makes the service more reliable and enables them to do additional trips. So that in and of itself and how the signals operate is also a safety mechanism. Vehicle storage. So we, as part of Eglinton Crosstown, for example, you might have heard the term MSF. So it's the maintenance storage facilities. That is important in terms of how we secure the vehicles, where they're stored, where they're maintained, how the frequency of maintenance is the appropriate facility in place to ensure that the vehicles are maintained properly and therefore safe. Fleet. The fleet is, we can't say too little about this because of course that is determined by the demand, so the projections or current demand from customers. It determines length and size of platforms. It determines in some cases speed because of gradient. So I try to identify mainly infrastructure elements that would further contribute to the discussion that I'm going to have. Next slide, please. Okay, so improving plan and design of stations. So many of you might be aware of fringe level of service. And that has almost become a basic consideration in designing most stations. And it affects platform as well as circulatory elements, the demand for circulation elements, platform width. In terms of, it is affected by service frequency. So in looking at all of this, you have to look at a comprehensive picture. So we're looking at level of service, but we're also looking at how it is impacted by the circulation elements you have, the frequency, the dwell time, and of course the dwell time is going to be affected by the kind of vehicle you have and the time it takes to open and close the doors. I can recall very specifically when the TTC changed the fleet to what we then call the Rocket, but they're now the trains on line 1. Part of the issue that we had was the doors for the newer train opened slower than the doors for the old trains. So it made it the running time required for the service increased. And before we could change that running time, it led to delays and gaps in the service, which led to overcrowding at some platforms and therefore made the service unsafe. So the fleet and the operation of the fleet and the characteristics of the fleet certainly has an impact on your level of service and therefore on the safety of your stations and your platform. Of course, the number of customers boarding and alighting at each station is going to be what contributes to overcrowding, and therefore in order to get these people off the platform as quickly as possible, we have to consider the platform width, the vertical circulation elements, and the other things that were mentioned previously. Next slide, please. Okay, so just to look a little bit more to get a better understanding of what Farin was talking about. In designing most services for the different components of the station, we have a rating going from A to F, with A being the best and F being the worst case scenario. In most cases, you try to get to C because, as you can see by the picture graph at the top there, is that at C, you're still able to have a good circulation for all people. It's accessible, whether or not you're able-bodied or you have a disability, you're able to move around. Level of service E, yes, you can still move around, but then you need to be looking futuristically when that would reach to the level of service F, which is then at that point, action definitely has to be taken. So somewhere between that orange color and red, you definitely have to be thinking what can be done to improve passenger circulation on your platforms, reduce overcrowding, and possibly avoid people falling onto the tracks or getting too close to the edge of the platform. Okay, next slide, please. All right, so let's look a little bit more closely at station capacity. Passenger modeling is often used in designing most stations. You look at the passenger modeling to look at flows. So you look at flows, whether it's along a walkway or going up an escalator or down an escalator. For example, you usually have the greatest flow movement in the direction of the flow. There are, for example, some stations on Line 1, TTC Line 1, where the elevator direction is reversed both in morning and evening peak in order to accommodate the direction of mass flow. Because the intent, of course, is to clear the platform as quickly as possible and avoid unsafe situations. All right, so that's one. Then you have your vehicle modeling. So you're modeling the vehicle, and in most cases, these models are done pre-implementation. So you've projected the ridership. You know the number of trains that you need, you know your service frequency that you need, you have a basic design of the track and its alignment, and you use all of that to test whether do a deterministic test. So you keep everything stable, and you say, can this service work safely? Can we operate this service based on the frequency that we require? Can we operate this service safely? However, the vehicle modeling also allow you to do what is called stochastic modeling, where you vary things, you throw in some delays, and you can do so many different options, so many different iterations to say, okay, what if an operator went to the washroom at the end of the line, so he was late? What variations do you have to make in terms of dwell time, in terms of speed along different segments of the line in order to maintain your schedule? So but in most cases, in planning for the stations, we do the passenger modeling separate from the vehicle modeling. I was in an environment where they were actually done by two different sets of people, and they never came together until the whole analysis didn't come together in one report. So you had the vehicle modeling as one report and the passenger modeling as one report. But recently, it has people have come to recognize that integrating the vehicle modeling and the pedestrian modeling, the passenger modeling, actually makes more sense and give a more realistic picture of how one influences the other. So I know there's been work done by different groups of people, but I can give reference to the work that Amma and pronounce the name of the other person had done, Reunion Station, where they brought this together and used one platform, and trying to stay away from mentioning names, use one platform to combine the two different models and to produce an output that was more realistic and could then be applied. As part of station planning as well, one of the things that I would like to mention is the strategy of what is called crime prevention through environmental design. This is not very applicable to underground station. Yes, it still is applicable to underground station, because where you have wide open platforms where people have line of sight for a much larger distance, and you have less turns and curves. Because I remember, for example, the first time I went to New York, I wouldn't use the subway, the train stations in going to Manhattan, because I was just so scared. The first time I went down the stairs, I went around the corner, I ran straight into an homeless person because I couldn't see around the corner. So we'll try to, through crime prevention design principles if it's at surface level, you usually try to make it so that the materials used, you can see from outside the station what's happening inside. For stations that are on the ground, it's more about wide platforms, line of sight, being as less columns and obstructions within the way, so people can actually have of line of sight as to what is happening on the platform. So I thought I would mention that because of some of the stuff that are happening. And of course, we have a lot of design that's currently happening. And these are some of the design standards that I think Metrolinx have incorporated in their design of this, the subway program that they're having. Next slide, please. Okay, so I just talked about FURIN and the level of service. Now that was applied here by the TTC on Bloor Young Station, and it was looking at 2031 AM peak and what would happen if nothing was done to improve the capacity of the station, but all the different expansions took place. So the Ontario line would be extended to the north. Eglinton Crosstown would be open. You would have possibly Ontario line. So if all of that happened, what would the crowding levels, the level of service look like on both line 1, the platform for line 1 and the platforms for line 2? And here you're seeing a lot of reds, yellows, and orange. So that is indicating to you that by 2031, we would be in an unsafe position during the morning peak because of overcrowding on those platforms, both on, as I said, the young side, on the Bloor side. So if you look, you will see that to your left, that's the young platform, and to your right, in horizontal, that's a Bloor platform. And both of them have indications that they would be beyond overcapacity, and therefore things need to be done. Now, before the TTC reached the point of introducing the Young Bloor Capacity Improvement Project, there were a number of different things that was done to actually reduce overcrowding at that station. So I can recall, for example, back in 2018, when they introduced spare trains, I'll call them for now, which were injected at specific times of the morning at a specific station in order to be at Young Bloor to reduce the congestion on the platform. Now, in order to determine at what time and what stations this needed to be done, it took a lot of manual manipulation of the data. Today, that has become much easier and can be done much faster. So in terms of planning and looking ahead, they're now able to do that. Well, maybe not the TTC, I'm not sure what they have acquired in terms of software, but that can be done much faster, and I'll get into that at a later stage. But that was, they did crowd management as well on platform in terms of direction, indicating markers on the floor for people as to where to stand to spread out the load on the platform itself, so everybody was not congregating around the stairs and making that situation even more unsafe. So before they got to the point of construction and changing stuff, they actually did a number of different things. But looking ahead to what was going to happen, it was decided that finally, yes, they would get the financing that was required to implement the capacity improvements. Next slide, please. Okay, so now we're going to continue on the same course where we're looking at how to improve the vehicle operation modeling. So we look at the passenger modeling. We saw where, just to summarize, in doing that, you needed to have different things. You had to have the dwell time, you needed to have the projections for ridership. But so that's one. But now let's look at the vehicle operation modeling. So in looking at this, you virtually need the same components. So we but you need here to have the alignment for the track. You must absolutely know what your track alignment is going to look like, or some preliminary designs. The vehicle characteristics is important. The signaling system and the track routing and the timetables. So whether you're going to simulate based on the fixed timetable, or you're going to introduce delays into that at predetermined location to see how the system would react, and what would need to be done in order to make the system operate safely. So that was done. I've done some work in that area, and I think the next slide this next slide is actually some work that was done for a single line operation design, where the trains would be operating at 12 minutes frequency along a single line, and therefore we had to determine what dwell times needed to be at those passing locations. So what would be the dwell time at these locations that would be required in order to ensure that you did not have any collisions, and that the throughputs were operating on time, and that the trains should get to the different ends based on the required, if you're trying to determine if the schedule would work, based on the determined layover at both ends of the line. So in this case, the dwell time for stations would range from just over 20 minutes to almost 10 minutes at the end of the line. And that is demonstrated there by that clock-like thing that's showing there. And you'll see that at some parts of these lines, it's not possible to pass. So therefore, you have to make sure you don't have to, we are now at the stage where we don't have to build it to test it. We can actually test it using the models to ensure that it is the service that is designed with the vehicle that is assigned will be able to operate safely. And that this was done for both directions, north and south. Next slide, please. Okay, so if we go back to Young Bloor, what we found was that as part of the Bloor-Young capacity improvement, there is plans to expand the northbound and southbound platform. So if you look at the picture to your right on top, that's an example of what can happen or what has happened at Bloor-Young station. And you can see how some people are actually standing on the tactile strips. So that's how crowded the platform can become. And therefore they can be contact with trains if the trains come in at certain speeds. And this is a situation you totally do not want to have as part of your everyday operation. Now, if you look at the platform below that, that is a draft of what is going to be when this is all done. And for those of you who might recall Union Station before the expansion, it is somewhat similar to what is happening at Bloor-Young. So the hope is that when the construction is done, what we will have is a more safe situation where circulation on the platform is, you have that 60-meter platform where circulation is much better, and you have more vertical circulation elements so that people can get off the platform much faster than they currently do because of the limits that you now have. Also on line 2, there will be a second platform, and that's both east and west. And of course, there will be a new exit on Bloor Street. As I mentioned before, you have additional circulation elements and new escalators and elevators. And of course, it all ties back to the accessibility for Ontarians and that their accessibility standards and of course the City of Toronto building standards and TTC criteria for building their stations. Next slide, please. it is amazing. When I found this picture, this photograph, I was like, wow, this goes back, this problem goes back so far, and it shows how unsafe the whole operation is. People can hardly get off the train. So, and this was back in 1973. So of course, this will increase the dwell time at the station. It will cause service disruption, and it will have to, what usually ends up happening is that at the central control office, now they have to now manually make the adjustments to the schedules in order to prevent too many trains from backing up and not having enough space to operate between each other, and to ensure that people have enough time to get off and on trains. So having crowding on your platform can have significant negative impacts on your operation as well as the safety of your passengers. Next slide, please. Now, bearing all of what we're seeing in mind, in the design of Eglinton Crosstown, for example, there are certain safety measures that have been put in place as part of the design. And as part of that design, all 15 stations will be equipped with a Guideway intrusion detection system, commonly known as GIDS. And these will be using laser scanners to sense when people and objects enter the tracks. So you don't want anything falling on your track, but you don't want people like going through the fence either. And I've been on GO trains too many times when it gets stuck because somebody got hit. So it is important that we have these detection systems that will prevent that, because it's not just it's the loss of life, it's the service inconvenience, and the whole service breaks down. In addition to the GIDS, there will also be installation of platform warning scanners above the yellow tactile strips. This is a first in the GTHA, and this will sit on the edge of the platform. Now, in the event that somebody steps on a tactile strip, the scanner will trigger an automatic audio message that will play over the station PA. Now, this is going to become very annoying for people who will, if the station is so crowded that people cannot sit back, because the message is on a loop and it will play until that detection is no longer there. Right, so the photograph you have there is the station is not yet open, but it is actually showing you what it is going to look like. Now, usually, next slide, please. This one is here. I'm trying to demonstrate some of the different detection systems that they will have, that you can have and will have in stations, to prevent people from intruding on the tracks or going beyond publicly accessible areas that they could be endangered. So you have platform indoors that's been shown in the picture to your right. You have platform detection system and intrusion detection. Some of these are used but operated by laser, as we saw mentioned in the case of Eglinton Crosstown. Next slide, please. Okay, so now we're in actual operation, and I'm going to talk a little bit about how these things can be monitored in order to improve and maintain safety. So in a lot of instances, people will talk about the use of platform edge doors, but where you have an existing system, it becomes very expensive and very difficult to implement those. So you do have, for people who travel to Vancouver, for example, where they have unmanned trains, a lot of their system has these platform edge doors. So people are not able to get onto the track. The doors only open when the train comes to the stop at the station, and then you can enter. So that keeps people away from the track and reduces that exposure. But for most systems, you have CCTV that monitors the platform, and you have a mass detection system, which is monitored by the onboard trade communication system, which if the operator does not stop the train, then that ships in and it automatically stops the train as long as there's a certain level of distance between the intrusion, when the intrusion was detected, and the response time. So these are usually programmed as part of the whole detection system. Now, there are times when the platform becomes extremely overcrowded because of people alighting the train. And what some stations do, what some operators do, is they actually program the fare collection gates to operate more slowly. So in order to allow people to leave the platform, you then make people come into the station at a slower rate. What this does, however, is that you find your congestion happens at the gate, but then it is safer to have the congestion at the gate than on the platform. So some companies, some operators tend to do this. However, this is usually done on a program basis. It's not reactive, it's not on the fly. Where we want to get to is you have these surges that will happen, unplanned surges. How do you fix those when they do happen? And this is where AI comes in, because manually we're not able to process all the data to do these automated adjustments. But with AI that can manage all of the data and process big data at a much faster speed, then the persons who are monitoring the system can therefore make the decision at a much faster rate to actually change the direction of flow or change the speed of the gate, or whatever elements that need to be changed in order to clear where the congestion is happening. So that's one of the things. For example, I don't know how many of you are familiar with NEOM. It's a proposed carless city in Saudi Arabia that has become very, very popular in terms of the amount, the amount of technology that's being proposed for it. And one of the things they're looking at is how to automate service frequency, how to be able to adjust service frequency on the fly. So you have a schedule, but your schedule is more reactive. It doesn't take, like in most cases in transit operation, months to make an adjustment to your schedule based on the information you're getting to say when the crowding levels change. In this case, you'll be able to react to variation in crowding levels as it happens. We also can use AI to use for video analytics. So, video is large data. So using AI to analyze data, you can detect potential issues such as aggressive behavior or furtive behavior. Now, in NEOM, for example, they want to take it a bit further. They want to actually capture personal data. So you'll have data on, let's say, somebody who has a criminal past, and you will be able to track that person as they move to the system. Now, the question is, how far do we want to go? Do we want to really intrude on people's personal data to do this? And worst of all, I think there's a proposal to pay people to allow them to use their personal data. So yes, there is need to improve security. Yes, there is AI. Yes, there's lots of data, but at what cost? How far do we take this? Where do we want it? Where will it all end? Next slide, please. Okay, so we're almost at the end. So here is where I would like to talk a little bit about collaboration. So we have seen that a lot of research has taken place, that technology is evolving, modeling is evolving, passenger modeling is evolving, vehicle modeling is evolving. There's been an integration of both. There have been a lot of tests done, but how do we actually work together to apply this? For example, the Ontario Centre for Excellence have said that the exhibition area is a virtual transit lab. that we can implement and test things. How many projects are currently happening down there to test some of these proposed technology? Yes, we work on stuff, but for example, you have the subway program that's now taking place. Metrolinx has awarded a contract to Unexpress, but Unexpress, and they did have reference concept design for stations, bridges, rail tracks, all of that. But they're actually going through a process now of what they call their development phase. So they're relooking some of these things. Can we apply any of this technology to, let's say, station design and modeling in order to improve the operations and safety of any of these lines? And how will the conversation evolve? Where do we take it in order to, for academics to be linked to industry professionals, and we bring the whole thing together and test it and then implement? So I think I'm going to end by saying we have made a lot of advancement in terms of planning and improving safety of transit, but it's now I think the challenge is now, how do we get this applied in our sphere? Yes, I know for sure that a number of the companies that bid on the Metrolinx packages for subway and GO expansion did use vehicle modeling and pedestrian modeling, for example, but they use them separately. It was two separate things in most cases. How do we bring it together and make it more efficient? That's where we're heading now. That's where the industry is heading. How does Toronto benefit from that? So those are some of the questions that needs to be further explored. And I think I will end there. Thank you very much for listening to me this afternoon. And I hope I was able to bring some light on this whole question of planning and preparation for improving transit security and safety.
Excellent. Well, thank you so much, Jacqueline. This is really indeed very exciting. It really overlaps. I mean, what you talked about, a few things that definitely I think the research community and us at TAL in particular have been pretty much active and trying to make some contribution towards, like you mentioned, the integrated simulation. That's something we've been working on for quite some time. We still have ongoing research in that area. I'm very happy to hear that the industry is recognizing the benefit and the strength of such approaches, and to put them to use in planning and operations management. I was also very intrigued by the adjustment of adjusting the programming of fare gates to delay entry of at overcrowded platforms. Is this an idea? Has it been implemented anywhere?
It is an idea that they have at, I know they have for NEOM. I think it has been implemented in some of the stations in London. I guess. So yes, it has been implemented, but I know NEOM, for example, is definitely exploring it.
We actually have 2 PhD theses that touch on this topic at the moment here at U of T. Anyway, we have a number of comments and questions. So let me start with one question from Jack. What about Paris line 1 and 4, where they have installed platform edge doors, which were installed for under 400 million euros? So yeah, the question is, why don't we consider implementing PEDs here?
I know for a fact that it was considered for line 1, but the cost was prohibitive at the time. I don't know if there has been any recent revision of those costs. As I said, the trust seemed to be to explore different technology in terms of what is being implemented at Eglinton, and we'll see how that works. But for now, that conversation is not front and center in terms of putting platform edge doors on our existing lines. I'm not sure if it's going to be part of Ontario Line, since it will be unmanned trains. It should be. So we might see some of that here in Toronto. But for now, I think the focus is on improving the capacity of the stations on Line 1, and not because, of course, financing is limited. So where do you spend the money?
That's good. Yeah, also let me remind everyone, if you have questions, you can put them in the chat, or you can use the raise hand tool if you want to speak. We have a series of questions from Faraz, because I guess you touched on a few topics of his PhD thesis. So his first question is, what data the AI-enabled gates will be using to determine the appropriate flow? So, which is, yeah.
It would be the fare card data. So
okay.
in stations where you have free body transfers, it wouldn't be very helpful. But in stations where you have to actually either tap or something, or indicate, use your fare card to enter, then that it would be. Or some of these fare gates actually have counters in them. So once you go through the fare gate, that data would be registered.
But if I understand Faraz's question clearly, like, you actually want to respond to overcrowding at the platform. So how do you sense the overcrowding at the platform?
Well, okay, so you have two things happening. You have people coming in and people getting off the trains.
Correct.
So getting off the trains, that's where you would have the counts from the train itself, right? So then that would be able to, and then you'd have the count going on. So it's a two-way flow. So on the platform itself, it would have to be the counts from the train.
Okay.
For trains that are so equipped.
Okay. Yeah, that's very interesting. His second question was related to the software, simulation software that he used to calculate dwell times. He's asking about the software, but it's up to you whether you want to answer this or not.
Yeah, as I said before, I'm staying away from mentioning any, because I'm not trying to promote any right now.
That's fair enough.
If he wants to have a private conversation, then we can.
Okay, sounds good. Yeah. So for us, that's an open invitation to reach out to Jacqueline and maybe ask her some of those questions. His third question was about whether, in fact, you actually have an integrated train and pedestrian simulation software, whether macro or micro. You talked.
Most of my research was based on the work that you have done, and it was how you use that software in between to to merge both. So currently, I did not find any that was already off the shelf that was integrated, but I was very intrigued by the work that you've done, and as I said, these are some of the research that needs to continue and some of the progress that we need to make so we can actually have a software, one platform that does both.
Yeah, that's will be great. I mean, if we can find the formula for collaboration, we'll be ecstatic really to extend some assistance and help and customize our software to your needs. Okay, another question here from Jeremy. How do you best handle practical concerns with AI for transit security, i.e. false positives, supervision, etc.? This came up a lot as a major roadblock to implementation when Jeremy did some work on this a while back.
Okay, well, that's still the $1 million question. And that's why even in where you have these operation control centers, you have AI, but they're still manned. So because they're decisions that still has to be taken by a human, because as you said, you do have false positives. You do have sometimes indication that something is on the track when something is not. So that's why the driver, for example, on a train is the first response. When he fails to respond as it gets closer, then the automatic response will come in. But yes, you do have false positive, Jamie, and I don't think they have discovered a way yet of totally eliminating the false positive. And that's why most people are still saying the best way to protect the track and intrusion in stations is the platform edge doors.
Mm-hmm. Which are too expensive.
Yeah. They're trying the laser, so let's see what happens, how many false positives they do have if they report on that. I didn't find any of that data yet, but I'm sure somebody's keeping track on that, and then it might push the conversation and the research some more as to what else can be done.
Yeah. That's great. Any other further questions?
Yeah, I have a question actually, if no one else has any question.
Okay, go ahead, Faraz.
Okay, yeah, so you talked about using the smart card data from the gates. So do you think that data is available like promptly in real time to be used by the AI enabled gates?
It depends on the system you have. So with what we currently have here in Toronto, I don't think this generation of Presto is so yet enabled. I'm not sure. I've been out of the Presto conversation, so don't quote me on it. But there are systems where they can get that data on the fly.
Mm.
Yeah. So, but I know the next generation of Presto was supposed to come in, and there are certain things that were supposed to come in it. We had to do a lot of post-processing when I was part of that arena. I am not sure how it's being handled. What's for the next generation of Presto? But that's where the industry is going for sure.
Good. We have a couple of questions from Willem. So in your extensive experience, Jacqueline, to what extent do you find people value safety interventions in terms of what people are willing to pay for things like platform edge doors and so on? And as a follow-up, he's asking, do you think updating safety features on existing lines or spending more money for safety features on new lines is considered equally important as serving more people?
I don't think we should measure whether we should update safety features on existing lines as opposed to new lines, because they're both important. You have some people who are transferring from the existing line to the new line, so they'll be benefiting from both. But in terms of whether or not people will be willing to pay for it, it's right now in this current situation, I would say no. What it would take is education. And right now, the emphasis is more on personal attacks, that's on the platforms, than protecting people who are falling onto the tracks. So if that becomes a major issue, I am sure you'll have outcry and you'll have people who are saying, well, yes, let's pay for it, let's get it done. But right now, I think the emphasis is more on platform surveillance in terms of what I mentioned, identifying people who might be displaying aggressive behavior or furtive behavior to, let's say, leave an incendiary device or something like that. But in the present economic situation with inflation and the decline in real income, I don't see people wanting to pay additional costs to implement some of these safety features unless they're educated to the point where they understand how these accidents, when they do happen, affects them personally. Once we get that acceptance, then I think it might be something that people will be willing to pay for.
Yeah. Great answer, thank you. We're almost at the hour, so if there's any pressing question anyone has, that's your last hour. I think there's so much more to talk about, but I think we're out of time. Thank you so much on behalf of everyone, Jacqueline. This was very insightful and a lot of exciting information about really what to expect in the new lines that are being implemented now. So, well, thank you again very much. And thanks everyone for joining us, and hope to see you again in the near future in the next event. Thank you.
Thank you so much for having me. Good evening, everyone.